Welcome to Pipeline Conversations, a machine learning podcast by ZenML.
This week, we dive into the abstractions that we're all trying to layer on top of the core ML processes and workflows. I spoke with Phil Howes, co-founder and chief scientist at BaseTen. BaseTen is a platform that allows data scientists to go from an initial model to an MVP web app quickly. We got into some of the big challenges he had working to build out the platform, as well as the core issue of iteration speed that motivates why they're building BaseTen. Phil has experienced quite a few of the industry's end-to-end patterns in the years that he's been working on machine learning, and it was great to have that context inform the conversation as well. As always, show notes are available at podcast.zenml.io, and if you have any suggestions for future guests, or even would like to nominate yourself, drop me a line at podcast@zenml.io. Without further ado, here's the show.
So my name is Phil Howes. I'm the co-founder and chief scientist at a machine learning company called BaseTen. Originally from academia, I guess I'm kind of like this recovering academic. I made this transition from mathematics into the sort of startup land, primarily beginning as a machine learning engineer and sort of like what I would call a full stack machine learning engineer, where basically I'm doing everything from data pipelines, training and deploying models, building like downstream applications that are sitting in front of users or internal operations teams or that kind of thing. I moved to San Francisco about 10 years ago, sort of on a whim. And I kind of immediately fell in love with the place. I thought there was just so much opportunity here. I don't know, it felt right. I was doing this full stack machine learning engineering, and after some time, I actually started my first company with my old friend called Tuan. And basically what we're trying to do was some greenfield kind of verticalized machine learning product. And that was the first startup. And I guess we failed a lot, but we learned a lot, and I think we were fortunate enough to sort of have made some pretty good progress. And to that end, we were acquired by another larger company in the space. But immediately just, entrepreneur, scratching those itches. And we immediately started working on something else, which eventually became BaseTen. We were thinking about other opportunities in the machine learning space, and we kind of got obsessed with this idea of kind of last mile for machine learning. So lots of data scientists, ML engineers, they're training their models, and then it's kind of okay, well, I want to see this thing in production. I want to get this thing out of my Jupyter notebook and into the hands of users or the internal team that's going to be using it. And that kind of obsession around solving that problem is kind of where we ended up kind of formulating some hypotheses around what kind of tooling would need to exist there. And certainly it combines a sort of spectrum of ML ops and application building. And we started BaseTen, and basically we've been running this company for about 2 years now, building relative stealth. We had small number of customers that we were sort of building pilots with, and growing the team. And we launched a few months ago publicly, and things have been going pretty great since. Getting a lot of user feedback, doing the whole gamut of startup things now. Yeah.
So you, in your previous kind of life, you must have encountered, I guess, a lot of the problems that your current users are have to deal with, or you at least you're familiar with them. I was wondering maybe you could just talk a little bit about that kind of. I don't know whether you want to call it old generation of full stack ML engineering. What does that look like?
Yeah, I mean, I think so I think ML engineering might not have really been a commonly used term maybe like 10, 15 years ago, and like data science, even data scientists, I think DJ Patel was originally started talking about data science like, well, I'm not quite sure, but certainly it's a term that's kind of like evolved over time, and initially data scientist, and to this day, data scientist is a very broadly uh, defined term that can sort of like encompass all sorts of things, from doing like analytics to training models to sort of like building machine learning systems. Um, and in my naivety, I thought like, okay, well, to be a good data scientist, I need to do all of those things. And so I sort of like took it upon myself to sort of do a lot of learning and sort of becoming, I guess, sort of jack of all trades, master of none kind of thing in the machine learning world. Um, and that sort of like, as I said before, like this full stack machine learning engineering that kind of encompasses everything from sort of training, sort of data ingestion, ETL, training, deployment, building applications. And I think the realization is that like that sort of like set of skills is actually very rare, and people are much more specialized, right? And so the people that we generally spend the most time talking to, like, are just sitting, they're doing a lot of like model building, and they're talking to domain experts, and the sort of like artifact of like all their efforts is like a machine learning model, and they're like, hey, I have this model and I want to use it in production, and it's kind of like, okay, what are all the different systems that need to exist to make that thing happen? And it turns out that like that is in general a very difficult problem to solve, and it's very domain specific, and there's all sorts of different requirements. And like the thing is, like, the data scientists are not infrastructure engineers, they're not product engineers. um, in many cases they're not particularly good engineers. um, they're people that have a very specialized set of skills, uh, and to ask them to be more than that, I think is just like a suboptimal use of their time. And so a lot of our customers come to us and say like, hey, help us get these models that we're building into the hands of like, let us unlock the value that's kind of like inherent in these models. Like, um, a lot of the people we talk to are like, models are a means to an end, right? They're about extracting some value that uh, kind of is inherent in data, and usually that value is in terms of like some business process. And so I think data scientists and domain experts are like pretty good at figuring out, how do I translate this business problem into a data problem? And data scientists are very good at translating data problems into data solutions. And I think there's kind of this like missing piece where lots what that's gaining a lot more attention, which is just kind of like, okay, how do I translate my data solution into a business solution? And that's kind of where we sit, and where I think companies like ZenML sit to some degree. You also support other parts of that process, and yeah.
I'm kind of curious, like, what how you see, I guess the way that these tools and I guess in general these processes are kind of marketed, or the pressures that exist for data scientists. Because on the one hand, many data scientists, obviously they want to be useful, they want to provide value and so on, and in whatever way that is possible for a team. And there are lots of tools now, whether it's Streamlit or BaseTen or whatever, that do allow people to get kind of some kind of MVP, or like that data solution in a business context, out there into the world. But I do also kind of see or detect, there's almost a kind of you're not complete as a human, as a data scientist. Like the completion of a data scientist is an ML engineer, or the completion of a data scientist is someone who can do the ops and the infra as well. Do you also see that kind of pressure?
Yeah, I see that pressure, but I kind of feel as though, like, you're asking too much. Like, specialization exists for a reason, right? Like, you want people to be specialized because um, they're just going to be much more effective of their job. And it's like really about picking your battles, right? It's a very different skill set and a different sort of like mind frame that you operate under when you're doing sort of like the real data science, which is kind of like building hypotheses around a process, and finding the right data and then doing feature engineering or like model architecting and training those models. And training models is somewhat of a commoditized thing right now. Like, there are just so many good frameworks and sort of tools to sort of like assist you in that regard. Uh, that's kind of like one skill set. And then there's another skill set, which is very much kind of like pretty close to sort of like traditional infrastructure engineering. Like machine learning ops is it's really like a set of engineering practices that are pretty disjoint from what a typical data scientist should do. And I understand that there's like this pressure for data scientists to kind of do everything, and I think like this is something of like an unfortunate consequence of the fact that data scientists kind of encapsulates so many different meanings. Um, and so and so like, okay, well, like, you're a data scientist, so you should be able to do this. Well, it's no, I'm a data scientist, and like, what we really just need is like more specific terminology for like where is the delegation of responsibility across like all the different thises a data scientist, like the title data scientist, can encapsulate. And so it's kind of like, I think it's unfortunate sort of like amount of pressure. I think it's something that's changing as people become sort of more aware of like how there are like pretty different sort of skill sets and responsibilities for like the different parts of like the machine learning value chain. Like, certainly, yeah, yeah. Uh, but coming back to your point, um, about sort of like, or should a data scientist be able to build applications? Should they like the applications kind of are particularly useful because the at the end of the day, like the 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 typical data science sort of project journey looks very like waterfally, right? It's kind of like, hey, like, define the problem, do like some exploratory analysis, train a model, like give it to some sort of like ML ops engineer to sort of like turn into some API, put it in front of like some sort of like product, so that the sort of like downstream users can kind of start to get a sense of like how this thing is going to work in their workflows. Like, machine learning gets very frequently used internally as well as externally, uh, and then sort of like get feedback. And so like, all of these things are just like require sort of like throwing the problem over the wall, right? And so I think, there's this like great opportunity for like, hey, okay, can tools like BaseTen and Streamlit or Hex or sort of like other sort of like general purpose kind of like abstract away some of these more sort of difficult downstream problems from model training kinds of tools. Is there an opportunity for them to come in and say, hey, like, let's leapfrog all of that latency in sort of getting feedback, and allow you with like very like without really having to learn anything new. Like, you don't need to learn about Kubernetes, you don't need to learn about like how to do containerization, you don't need to learn about scaling APIs, you don't need to learn about how to build a React app, like, with like some front end. um, you can just kind of like pull these different components together and immediately put it in front of like the stakeholder and start getting feedback. Um, and like, I've seen this being used in sort of like all sorts of situations. Like, quite often the data scientist wants to put something in front of stakeholders to get feedback on like, hey, does this like solve the problem? Is it well defined? Um, uh, you know, People building everything from sort of like labeling tools, all these different sorts of like human in the loop workflows, and like it starts that iteration process, which I think is like key thing to sort of like, the sooner you can start creating feedback loops, like the faster you can start optimizing like what it is that you're trying to solve.
So maybe it's worth going through just like a kind of an ideal world use case. What are the kinds of things that people are building, or what would be the kind of your perfect fit in terms of what you think someone would build with, or somewhere someone could get value from BaseTen?
So BaseTen is really about sort of like getting 0 to 1 as quickly as possible, right? Um, we're kind of a deployment tool, we're an application builder, and we're sort of there to sort of like make it really easy to build like full stack ML products. So very quickly, like, an example of that is like, okay, I have some model that is doing some, let's say it's doing content moderation. Okay, I have an operations team that's doing content moderation, and I want to basically try and like give them superpowers to do like only be looking at the content which is most relevant for them to moderate. And so I, as a data scientist, I'll have a machine learning model that I've trained on these operations team has existed. They're basically like looking at flagged content, and they're essentially generating like training data for a model. And so I built some machine learning model on this on this labeled data, and based on, we have this Python open source Python package that basically takes models from all the different like common frameworks, scikit-learn, PyTorch, TensorFlow, XGBoost, all these ones, and very quickly allows you to sort of like wrap that model in all the boilerplate to turn it into an API. Okay, so an API is the beginning of an application. And so with that, with like one line of code, we go, hey, BaseTen deploy, model thing, and all of a sudden, like, your model is now being served as an API in BaseTen. And um, and then what's like other parts of this application that need to be built? Okay, so like we have this kind of like serverless like workflow pipeline orchestration tool that you can sort of like write like all this business logic. So as new data comes in, I can do some sort of like ETL on that thing, run it through my model, get some prediction, and then like based off that prediction, I want to do some business logic around, hey, do I need to triage this? Can I put it in some backlog? Or is it like, perfectly fine? And so that's kind of like the back end side of things. And then you can build these with like this, what you see is what you get kind of like UI builder. You can start to build out user interfaces, and those user interfaces are the things that are being consumed by like your downstream users. So you can have like some sort of like kind of like list of all the different cases that need to be reviewed, and you can look at what did the model say. Here's like the data, and then like the human operator can sort of perform like various actions on that data, and we can we tie back into all your different data stores, so that as you continue to use this application, you're also generating more labeled training data.
And so what are the Obviously, you're concealing a lot of complexity away from the user there. Like you're doing a lot on the base 10 end. Like what are the hard pieces of this that you've really kind of had to struggle with to make it work?
Yeah, I mean, certainly, I think like, uh, I mean, there's there's kind of like the technical challenges and then there's product challenges, right? And so like at a product sense, it's universal. It's about figuring out what is like the right abstractions and sort of hooks that so that like the user feels as though like there's this like seamless transition from, hey, I'm doing things locally to like, hey, now I'm running in the cloud, and being able to sort of like feel like really good about the experience. And then I mean, that's always hard to figure out. And then uh, from the technical standpoint, oh boy. So I mean, what we're trying to do is basically allow thousands, tens of thousands of machine learning models to run. Basically, we are orchestrating like all the infrastructure for basic all the different users, and we're trying to do it in such a way that like all of these abstractions exist so that you don't have to do any of the hard stuff. So basically, we're being delegated the responsibility of taking everybody else's problems away. And that manifests in sort of like, oh, how do you manage these huge number of resources at scale? Um, yeah, that that's the stuff that keeps
How
me
do
up
you
at
do that?
night. Well, okay, so I mean, like, obviously, just like most companies, like we stand on the shoulders of giants in terms of like there's just so much good open source software out there. We use very heavily use things that have already built very good abstractions. Kubernetes uh, provides like a very good way for us to sort of like define workloads, and that whole ecosystem is just full of things that sort of like plug in really well. So like, if we want to do monitoring, there's all sorts of tooling out there for monitoring, like Prometheus, like logging, Grafana, Loki. Um, in terms of standing up serverless inference, like we have, Knative is like a good low level set of abstractions for like building out serverless tools. So we basically we basically orchestrate all of our workloads by sort of like combining sort of like best in class, and combining and sort of like extending best in class kind of like open source tools. um, yeah, and then I guess one other like really challenging thing would be, um, you want the experience to be sort of like as magical as possible, right? So there's always this like tension between sort of like creating really uh, magical experiences and providing enough sort of flexibility to cover all the use cases, because like magical experiences is like happy path, right? And the thing is, in the real world, there's a lot of people traveling on the unhappy path, so how do we make sure that things are sort of open and flexible enough to enable like all of the different use cases, for the 90% of people who are doing sort of like pretty standard things, like it's all just sort of like boom, 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 done, done, done. Like you've got your application up and running, but also being able to support people that have like more complex requirements.
And that so much is abstracted away somehow from the user. I'm kind of curious how you handle um, perhaps the unhappy path, like what happens when things fail. Because when I think of magical experiences, I don't necessarily think of the 5-line train a model. I think of something went wrong, but someone took time to write the perfect error message, which will allow me to figure this out, or like
Yeah,
it's preserved perfectly in the logs somewhere.
yeah, sure. So I think like observability is a huge thing, right? You really hit the nail on the head there. Like, is um, people are going to run into issues, and being able to sort of like trace back, hey, how how do I take this error message and sort of trace it back to my problem and sort of like root cause it and understand like how do I triage it, and giving people kind of like the surgical tools to sort of like cut through our abstractions and get down to the actual nitty gritty, right? And so I can kind of give an example here around. So we have this sort of containerization, like model containerization package that we've built. It's called Trust. It's an open source package, um, and it's kind of like this layered abstraction. So in the happy path, you have this like one line kind of command which will take like, hey, I've trained my model, got my PyTorch model that's in memory, and I want to basically serialize that model, wrap it in some boilerplate kind of like API serving code, like, hey, like I'm a data scientist. I'm not like an engineer that like really thinks about like concurrency and all the other considerations. I want someone else to write the server for me. Um, and so Happy Path, like you just get all that boilerplate. But uh, in the sort of slightly unhappy path, there's kind of like, hey, there is this config file that you can. So the trust that gets generated, which is like our name for kind of like this sort of like self-contained uh, uh, scaffold. Um, uh, the trust is kind of like one layer of abstraction. So it gives you some sort of like knobs to turn, um, and allows you to sort of like edit some of the code. And then there's like a deeper abstraction, which is basically, hey, template out everything down to sort of like, hey, what's going to be in my Docker container. And when you're down at that level, you can sort of start to move things around very like carefully. You can start playing with the Docker file, like, hey, I need like this particular version of this thing because like I have this weird requirement and like there's all these like version conflicts, and I need to be able to get down to that level. And so yeah, magical experience is kind of like right up the top, and then you sort of like have these ways to sort of like drill deeper and deeper and deeper until you sort of like get down to like, hey, this is what's like running on the metal.
So when you're working on building, I guess some kind of abstraction or some kind of higher layer on top of other things, you yeah, it's normal or maybe expected that you would kind of encode in or embody like the best practices of that particular domain or whatever you're trying to do. I'm kind of curious what your take on best practices for this kind of thing are.
Yeah. I mean, I guess best
Sorry for the
practices
big question.
best practices in ML. I kind of feel as though like it's kind of like oxymoron at the moment. It's still the Wild West, like everybody, like, I mean, you could just have to look at the space and look at how many tools are in the space popping up. I mean, like, you and I work in this space, and everybody has decided that there are different types of abstractions that should be built. And so like, this is obviously like going to be opinionated, but I think best practices. I think what we can do is like maybe learn from some of the other engineering disciplines, like to the extent that we can. Um, obviously, building and serving machine learning applications is a pretty different paradigm. Like traditional engineering is very deterministic. I write this code, it does exactly this. Machine learning, very different paradigm. You're thinking about things probabilistically, and so the kinds of abstractions that end up getting built, and the kinds of tools that are needed to support that kind of thing, are somewhat different, but there is some overlap. And so, for example, okay, let's think about sort of like serving models. Uh, model traffic. Okay, let's talk about online I mean, like, there's just so many places we can go here. Like, online serving of models is kind of interesting in the sense that the traffic patterns for model predictions is very different to sort of traditional web traffic. And so you have to be able to deal with like big spikes in traffic, lots of sort of like times of like pretty low traffic or even no traffic. And so like what are some good abstractions that should be built around that type of traffic? So certainly, okay, hey, if we want to deal with spikes, we should be able to do like scaling really well. Or, we should be thinking about, okay, well, um, you know, if not scaling, so in my world, we like to think in terms of traffic. We like to think, okay, scaling and queuing. Okay, so basically, all my my model service should be able to sort of both respond to increases in traffic relatively rapidly, and also be able to handle sort of more than what it's currently provisioned to handle. And the way that you do that is by introducing like queues. And so the abstractions that I have built, or we have built, is definitely like, we have this way of sort of like buffering the traffic, and in that buffer, sort of like reading off that buffer, be like, how big is that getting? And if that buffer is getting too big, let's start spinning up more instances. And like, this is something like, is this the domain of a data scientist? Certainly not, right? And but the idea is that, like, we build these abstractions, like, you like these best practices around sort of like serving models is certainly something that I think no data scientist should really be thinking about. And like, I'm very happy to sort of like see like the proliferation of tools that's kind of like putting their own take on the different on different things. Other abstractions. I mean, all along the way, I think there are some really good, like, just like quickly, like some really good other tooling that's like built out good abstractions, like DVC. DVC is great. Like, people understand version control. So hey, like, let's do Git for data. Like, that's a well established extraction, just kind of like mapped to our domain. Yeah, I don't. I can't really think of too many others. I mean, like, there's lots of pipeline tools, like pipelines are kind of like the bread and butter for sort of like orchestrating machine learning. That I think that there are like lots of really good abstractions around sort of like meeting um, meeting the practitioners, kind of like where they operate, like, as in like building very Pythonic libraries like decorators. I think ZenML is one of these tools that is like, hey, let's try and be sort of somewhat agnostic to the different implementations. And so I think, one maybe motivating abstraction for machine learning is just like, don't be like, you can kind of hedge against opinionated abstractions. Yeah.
Do you get the sense? I mean, there are lots of different different kinds of ML out in the world. Some of it working, quote unquote. Some of it not. Some of it maybe working for a few weeks, but maybe not in the long term or whatever. Yeah, like, just can I guess that just the diversity of all of these kinds of things, and the diversity of the different domains and the use cases that people are trying, and everyone's continually pushing the boundary all the time. Like, is there necessarily some like grand abstraction to come, or some kind of wider unified understanding of all of these things, or will just the fact that it's so varied in terms of how it's done means that we'll kind of exist in this this world for a while?
Yeah, that's a really good question. To to our point earlier about data scientists, the term data science sort of like referring to so many different things. I think this is also true of just like the space in general. Like there is such a diversity of problems and requirements that like the grand unified tool. I'm not quite sure if it's going to exist. I kind of feel as though there's space for a set of tools that kind of map really well to sort of like I guess there's kind of like there's different requirements for in so many different dimensions, like in terms of data size, in terms of like the modality, in terms of the inference requirements. And it's really hard to sort of see how something's going to sort of solve all of those problems. And this is kind of like why like I get kind of excited when people, like so many people, like are very quick to sort of dismiss machine learning companies and say, hey, well, like, how are you going to go up against Amazon and Google and all these things? And it's kind of like, well, there's it's such a broad space, and like they're sort of like they're not specialized really in anything. They're trying to be everything, but by trying to be everything, it's really hard for them to be anything. Um, and certainly, I think like where I've seen like the initial success in ML ops and sort of machine learning in general is when a tool is really good at sort of carving out their specific market and understanding that and optimizing for that. Because at the end of the day, like um, really tight like feedback loops is kind of like what people like draw people into products. And so it's really hard to sort of like think about like, oh, how do I build a product that just has like so many of those? And it's kind of like you end up getting this kind of like paralysis of choice as well, right? This is another problem in the ML world. It's just kind of like, hey, what are the tools that I should be using for my set of problems? It's really non-trivial to sort of like find what's the right set of tools. So in short, no to the question of the grand unified abstraction layer or tool.
So on the, I mean, one, I guess, embodied best practice that at least from the outside I see in BaseTen is kind of, um, yeah, prioritizing this idea of like speed of getting through the entire life cycle, at least until the point where you have something that's out there and visible, or something that's usable. I was wondering, maybe you could talk a little bit about this kind of speed of iteration, or that value, I guess, and the trade-offs that you see with it, the importance of it, like why prioritize this?
Mm.
And maybe if I could just add one thing on the end of that, like, what happens once you've reached that point at the end? Does that change? Like, once you have your baseline model out in the world, like, does the importance of that change? Yeah.
Yeah. I mean, I think the same lessons around sort of like building a company is the same lessons around that you could like learn around um, building machine learning applications. Like the quicker you get to putting your product or your model into production, the faster you're going to start getting feedback on that thing. Uh, Creating like the sort of like optimization happens in a loop, and the faster you operate that loop, uh, the faster you're going to be able to optimize the thing. And so like there are so many different parts to optimize, not just from like the model training, but sort of like what is the impact that the model is having, and like, you know, what are the hypotheses around the problem that I'm solving, that I'm basically getting signal on by putting that thing into production, and building the tool that's going to allow people to start giving feedback. I think it's really easy to sort of like one of the failure modes is like iterating too much on sort of like a solution um, before uh, before it's like in the real world. Um, Sorry, what was the last part, the little add-on you had?
Oh, just like how does that change once, I guess, once it reaches the world? But I guess you're saying it doesn't. You just keep on iterating.
Well, no, I mean, I think at the end of the day, like, you know, in the ML world, um, like distributions change, right? So you know, for a long time, you can kind of, there's like you're extracting some value, and the sort of objective functions kind of changing, or the data's changing. You can kind of follow the gradient, and like by iterating on that loop, um, until you can't, right? So until you have to sort of like fundamentally change something, like something like nonlinear has changed about the state of the world, where we need to sort of like start again from scratch, and sort of like you need to be very careful around sort of like constantly sort of like temperature checking. I guess like you don't want to be the frog that boils in water, right? Like, you know, this thing's working, it's getting better and better. But like, hey, is there something just like non-trivially different that we could be doing? And so I think it's about like that's a separate feedback loop that's operating at a much longer time scale. Um, and again, sort of, I feel as though I'm talking, I'm talking metaphorically, both about machine learning and about just startups in general.
Actually, what you said kind of just reminded me, or took me in the direction of a kind of a slight tangent. Just thinking about like education in this field, such as there is education in ML.
Hmm.
It feels like from what I know and from what I've heard people talk about it, like preparation for this world of iteration and so on, like this isn't really part of how this is taught at the moment. Yeah,
Mm.
I'm kind of curious on your experience of that. I mean, you came through academia and mathematics and so on. Yeah, was this something that you encountered as part of, I don't know, problem solving?
Yeah. So I guess I mean, like, just to clarify, like, you know, are you talking about sort of the way that machine learning is kind of taught as a discipline, like theory versus practice?
Kind of like the kinds of people who are coming into the workforce who are, trained in this somehow
Yeah.
as coming out as data scientists and so on. Like, to what extent is this part of how they think about things? Are they thinking of the full end to end cycle? Yeah.
Mm. Yeah. Yeah, I think that's a really good point. Like machine learning, I think is this kind of like romanticized thing, where it's kind of like, it's really like there's lots of like really sexy problems in machine learning today. Um, you know, large language models, generative models, like it's very sort of like seductive to sort of like fall into the trap of thinking like, hey, this is a purely kind of like research type field, and at the end of the day, like the majority of machine learning, in terms of like the value that gets created by machine learning, is around how do I automate or sort of augment some operational thing that's happening in like a business context. um, and so I think, you know, a lot of people coming into machine learning, um, they're incredibly intelligent people who have mastered a lot of theoretical sort of skill sets around sort of like how do I, they're a combination of sort of like statistician, mathematician, problem solver, with a smattering of sort of like engineering in there. And I kind of feel as though the ML engineers that kind of really stand out are the people that have uh, understood that machine learning is actually really a means to an end, and that end is creating value for in some way. I mean, obviously, personal projects, fun little toys, just for, like the value is, whatever delivers to yourself. But in industry, it's very much sort of like understanding what is the connection between this problem in the data domain to the problem in the business domain. And I think the more that ML engineers and data scientists can be thinking about how to transition between those two spaces, the more effective they are in their jobs. And it's something that I think is it's something that you kind of like learn on the job, I think. And like in a good workplace, like there should be like really good lines of sight between, say, hey, what am I doing and how is it impacting the business? And if it's not, then I think you should advocate for that to be the case. um the other thing that I would just say that sort of like sets apart uh sort of like the good ML engineers from the great ML engineers is just sort of like having the empathy for a bunch of engineering practices. Like, you don't have to be the best engineer, but you should know like some of like the tried and tested engineering abstractions, so that you're not creating too much of a burden for the people that you sort of throw your model over the wall to, if that's the case in your organization. And just in terms of like building building good process in machine learning sort of life cycle, I think like there's a lot to be learned from engineering. Like as a discipline, it's getting pretty old, and there are very well established best practices, and ML engineers generally aren't CS majors. I mean, certainly some of them are, but there there's a lot to be sort of like taken from those learnings.
It's kind of, if you are in the unfortunate position to be expected by your workplace to be the full stack unicorn, then try to rely on some of those foundational fundamentals that
Yeah.
will serve across whatever people might throw at you.
Yeah, exactly. And I think that there's like kind of a sort of inverse correlation between like an inverse relationship between sort of like company size and the amount that's expected from you. Like as the company grows, roles get more sort of like scoped down to like a very specific task. And 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 like, if you are somebody who wants to learn, maybe you want, like, you should take that into consideration when you're like, hey, if I'm at a small company, if I'm at a startup, I'm going to be wearing a lot of hats out of necessity, and I'm going to learn a lot. um,
Yep. I'm kind of curious. I often like to ask this, as sometimes weird answers come out. But if there are any like tools or services or things that you've worked with in the however recent past that like you love working with, that yeah, either get the abstraction
mm.
perfectly right or
Yeah, I mean, like, most of the tools I think that I really love are actually sort of like more on the engineering side. Like I love Visual Studio Code. Like I am a convert.
Mhm.
I converted like a year ago. I would live my life in Visual Studio Code if I could. If I
What did
could.
you convert from?
Oh, just like a mix of Vim and I would use
Notebooks.
Sublime. Yeah. But like I use it for note taking. I use it for coding, testing. It's my IDE. If I could use it for email and Zoom, I would. um, yeah, but I think on the ML side, like honestly, I think the tools exist. I think it's just a matter of yeah, it's really, I mean, Yeah, Knative. I really like Knative. I mean, I love open source software. To the best of my ability, I push our company in that direction. I think they've done a lot. They're sitting on they're sitting on the shoulders of giants. Also, like there's a lot of they're building abstractions on top of abstractions. It's abstractions all the way down. I just really like the ones that they've built.
Yeah. Yeah. Nice. So finally, we usually end with a couple of kind of more practical questions. Firstly, what would kind of be a quick win that someone could add to make their productionizing of models more robust?
Robustness.
Either technically or their behavior or
Yeah.
you want.
I mean, I think like, to the earlier point, I think it's like the tools exist, like figure out what is the right set of tools for like the stage and the size of your team. And with that sort of like pick your battles, right? Like, hey, are we at the maturity level where we should be building this in-house versus picking a good tool off the shelf that's going to do a really good job for us? Like there is a cognitive burden, like in terms of robustness, like there's a cognitive burden of like adding more tools, and with that you're losing your mind share to really be thinking about like the problems that you really should be thinking about.
Yeah, that's definitely a tendency towards over complexity and over engineering and all of that in this world.
Yeah, and I'm guilty of it myself.
And secondly, what is one's kind of bit of putting models into production and that whole world and life cycle that you feel isn't getting enough attention by tool makers in the MLOps space? Are there any big holes that you can see?
Honestly, I think like I think the ecosystem has enough tools. I think it's really just like we're just like a few iterations away from something which is like stable. Like there is the right set of abstractions out there. I don't think something's missing. I think what we have is like we got given a Lego set, uh, and maybe we have to pull it apart a little bit and then put it together in the right way. I think. Yeah, I don't think that there's anything missing. I think that we're just missing a few iteration cycles of people of like the tools that really understand like, hey, what are the real problems and how do we sort of like package and execute on our solutions to those problems in the right way so that people don't feel like there's something missing.
Very optimistic way to end. I will hold you. We're just a few iterations away.
Yeah, we're just yeah. Hopefully feedback loops. Let's try and make them fast.
Yeah. Well, thank you very much for coming on, Phil. Definitely was very interested to learn about obviously what you're building at BaseTen, but just your experience in general, having worked on this stuff for a while.
Yeah, thanks.
Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.